All right, continuing with the integral test. So we have, the last thing I want to talk about is the remainder. So for the remainder, notice I wrote my series already from n equals 1 to infinity raised to n, and so it goes on forever, right? This goes to infinity in that pattern. So when we talk about the sum of this, then this series is really equal to Sn, meaning from a equals 1 to a equals n, right? So that's Sn plus, and then you have an plus 1 plus an plus 2 plus the rest of it. So this is what we call the remainder, right? What remains of the series after you do a finite approximation. So we're going to call this Rn, right? The remainder for a given value of n. So that means we can write our entire sum as n equals 1 to infinity of a sub n plus, equals Sn plus Rn. Now from the previous picture and the work that we did in the prior video, we know that Sn is between, now remember, Sn, what did we say, is between 1 and n plus 1, the integral of f of x dx, right, where f of x is a sub x, replace all the n's with x, and a1 plus the integral from 1 to n of f of x dx. So that's what Sn is. So what does that tell you about the remainder? Now, this we can deduce that then the remainder, Rn, is going to be between what two things? The integral, right? So we're going to go past n plus 1. So from n plus 1 to infinity of f of x dx, and between then where we live off here, from n to infinity of f of x dx. So that's what the remainder means. And so one of the nice things about the remainder, notice that if the remainder goes to 0, then our series will converge. So back to the series that we were working on our example, prior example, if I let the series be from 1 to infinity of e to the minus n, then we already computed what S20 was. We did it in prior video, so if you haven't seen that video, go back and find it. So we did S20, so that means that for this series, n equals 1 to infinity of e to the minus n is equal to S20 plus R20. Right, so the sum of the first 20 terms and then everything that remains. So R20, what is R20? The remainder will be A21 plus A22 plus A23 plus all those terms forever. So can we bound the remainder? So based on this formula that we would like to remember, that means, so we have n is 20, so therefore R20 is bounded below by the integral from n plus 1 to infinity. So from n is 20, so from 21 to infinity of f of x, so e to the minus x dx, and the integral from n to infinity, so 20 to infinity of e to the minus x dx. We know the integral of e to the minus x dx is negative e to the minus x, so let's put that in here. So it'll be negative e to the minus x from 21 to b less than the remainder less than, I'm using my improper integral notation here, from 1 to b. So when you play it in, you're going to have negative e to the minus b minus a minus, so plus e to the minus 21 less than the remainder less than, same thing here, minus e to the minus b minus a minus, that was a 20, sorry, plus e to the minus 20. Now, as b goes to infinity, this goes to 0. So we're left with e to the minus 21. So 1 over e to the 21 is less than our 20, less than 1 over e to the 20. And so you can put that in your calculator and see how small our remainder is. So this also lets us know how close we are to the actual sum, right? So if the remainder is really large, we're not that close to the sum. So this is really, really small number. I got 7.58 times 10 to the minus 10, right? So that's very small. Less than our 20, less than, and then we do the same thing for the other side, which I got 2.06 times 10 to the minus 9. So the remainder is very small, so that means we are very close to the actual sum. And so in the prior video, which let me scroll up, these are still the same notes. I went over, we bounded as 20. So the sum of the first 20 terms is between 0.36789 and 0.73575. So that gives us a range for what the sum should be. Now the remainder, what this tells us is that the remainder is very small. So that means that S20 is already very close to the actual sum. And I remember that was a geometric series. So if you do the sum of the entire geometric series, as n goes from 1 to infinity, right, no longer finite, of e to the minus n, this is n equals 1 to infinity of 1 over e to the n. So as an infinite sum, we can find the sum by saying the first term, so 1 over e over 1 minus the ratio. And so if you do this, what we should find is that this sum, hopefully, is, not hopefully, it will be very close to our approximation for S20. So it will still be a number in here. We did find our S20 by doing the geometric, so 0.5819. So, but the general sum, so if you do, right, our sum here will be Sn plus R20, Rn. So the total sum, if it converges, right, that's S. So this will be Sn plus Rn. So our Rn is very, very small in this case, right? That's what I'm trying to illustrate. Your R20 is very, very small. So that means that S20 is already very close to what the actual sum is, if our Rn is very small. So, okay. So there you might be you might encounter some questions in the homework that ask you find the value of n that makes the remainder a certain amount. So that means you have the integral from n plus 1 to infinity and n to infinity, but you will know, like if you want the remainder to be like smaller than 0.1, then you will set this less than 0.1 and solve for n. So email me if you have any questions, and I'll see you next time in class.